Derivative of the exponential function is the easiest derivative rule in calculus, and it shows up everywhere. Master this concept, and you'll unlock one of the most powerful tools in mathematics. First, let's review the exponential functions. An exponential function has the variable in the exponent. Understanding this is key to mastering their derivatives. So first you have base e. That's the natural exponential function, and it looks like e to the power x. Or you could have other bases, that is any positive basis, for instance 2 to the power x or 5 to the power 3x. There are two main cases we'll explore: functions with base e and functions with base a or base not e. Here's the most important fact. The derivative of e to the power x is itself. That is, if we have dx of e to the power x, that is the derivative of e to the power x with respect to variable x, that will be equal to e to the power x. This property makes e to the power x unique among all functions. It's the only function that equals its own derivative, which is why e is called the natural base. Let's look at our first example. We want to find the derivative of f of x equals 5 times e to the power x. So our original function is 5 times e to the power x. We'll need to pull out the constant, that is the constant 5 stays in front, and we'll find the derivative of e to the power x, which is simply e to the power x. Therefore, a solution is f prime of x is equal to 5e to the power x. When you have a constant multiplied by e to the power x, simply keep the constant and the exponential function stays the same. Now let's discuss the chain rule with e to the power x. If the exponent is not just x, use the chain rule. This is where things get more interesting. So here's the rule. If you have the derivative of e to the power u with respect to x, where u is a function of x, the derivative will be equal to e to the power u times u prime, that is the derivative of u with respect to x. In other words, you want to multiply the exponential by the derivative of the inside function. Let's look at it through an example. We want to find the derivative of f of x equals e to the power 3x. So first, if we identify our inside function, the inside function is 3x, and its derivative is simply 3. So applying the chain rule, f prime of x will be equal to the derivative of the inside function, which is 3, times e to the power 3x. The exponential function stays the same, but will multiply by the derivative of the exponent. In this next example, we'll want to find the derivative of f of x equals e to the power x squared. First, we identify the inside function, which is x squared. Find its derivative with respect to x. The derivative of x squared is 2x. And then we can apply the chain rule. F prime of x will be equal to 2x times e to the power x squared. Now what if we have a different base? The derivative of a to the power x, that is when the base is not e. For any base a greater than 0, where a is not equal to 1, the derivative of a to the power x with respect to x will be equal to a to the power x times natural log of a. So that's the key difference. When the base is not e, you must multiply by the natural logarithm of the base. And why do we multiply by the natural logarithm? This factor accounts for the conversion from base a to the natural base e. Let's look at it through an example. In this example, we want to find the derivative of f of x equals 2 to the power x. So in this case, the base is 2, not e. So we'll want to apply the formula. We'll use a to the power x ln a. In this case, once again, our base a is 2. So f prime of x, that is the derivative of f of x with respect to x, will be equal to 2 to the power x times natural log of 2. So it's very important not to forget to multiply by the natural log. In this next example, we'll want to find the derivative of f of x equals 3 to the power 2x. In this case, our base is 3. The inside function is 2x. The derivative of the inside function is simply 2. So if we apply both rules, f prime of x will be equal to the derivative of the inside, which is 2, times 3 to the power 2x, that is our exponential function, times natural log of 3. So in this case, we'll combine the chain rule with the exponential derivative rule for bases other than e. Here's your challenge for today. Find the derivatives of these functions. Problem 1, you'll want to find the derivative of f of x equals e to the power 5x minus 1. You'll need to use the chain rule with base e. In the second problem, find the derivative of f of x equals 4 to the power x squared. You'll need to combine both techniques. And please comment your answers below. Practice makes permanent, and these problems will solidify your understanding of exponential derivatives. Once you master exponential derivatives, calculus gets way easier. These functions appear everywhere in science, engineering, economics, and beyond. Thanks for watching. Please like and subscribe. And don't forget, math success starts when you stay on the fast track.